Hi, this is the third part of our videos on common physics relationships that we see in nature, putting categories to the different things that we can see. This video we're going to start with quadratic. This quadratic relationship is one that you've probably heard of before. You've heard the name quadratic, I'm sure. For physics, in a quadratic relationship between two quantities, if you increase one quantity, the other one also increases, but it increases by the square of the factor or the change that you make. So let's look at an example to help make sense of this. Let's say you're freely falling to the earth, skydiving. The time that you spend skydiving, you're going to get faster and faster and faster. That means that if you measured how far you've actually fallen, if you increase the amount of time you fall, you're actually increasing the distance you fall exponentially. Think about it, right? In the first second, you don't fall very far because you're going kind of slow. You're just starting out, so you fall a little bit. But in the 9th second of falling, you're going much faster, and you're going to fall at a much more distance. And so this is an exponential kind of relationship. The more time you fall, the much farther and farther you're falling each second. So let's graph this just to see what it looks like. Let's say that we start, if you spend no time falling, you have no distance travel. We're going to start at the origin here, 0, 0. Let's say after 1 second of falling, or one unit of the manipulated quantity, let's say you've fallen a distance of 1 unit, whatever unit that might be, or for the responding quantity here. I'm going to try to keep the numbers simple. So 1, 1 will be our first data point. If we double that, if we double the amount of time, for example, times 2 here, how does that affect the responding quantity? Well, the responding quantity is also going to increase, but it's going to increase by the square of that change that we just made, by the factor. So instead of increasing by a factor of 2, it's going to increase by a factor of 2 squared, and 2 squared equals 4. So this original 1 unit of distance is now going to become 4 because it's squared. 2 squared is 4, so we double the manipulated quantity, we get times 4 for the responding quantity. And so this is that connection there. All right, let's take it another step further. Let's say now you've fallen for 3 seconds, or you've increased from 1 to 3. Okay, well, 3 squared is 9. So if you've fallen for 3 seconds, now you're going to have times 9 to represent the distance you've fallen. And so that's a big jump. We're getting into the exponential range here. Okay, so we're increasing quite a bit, quite fast. All right, let's do one more data point because I think we're about to run out of room over here. Let's say now we go up by a factor of 4 on the manipulated quantity. So 1 to 4, that's a factor of 4. 4 squared is 16. So we're going to increase from 1 all the way up to 16 on the responding quantity side. So at 4, we're going to be at 16. Okay, and so we have this, starting at the origin, we have this parabola shape that takes form here. And that would keep on going. And so this is an exponential relationship, a quadratic relationship. We write that equation like this: y equals kx squared. All right, let's look at one last example in this video. That is inverse squared. It's very similar to the quadratic because it's like a quadratic, but it's backwards. And what I mean by that is, for an inverse square relationship, when you increase one quantity, the other one goes down by the square of that change. So it's inverse. An example of this would be gravity. If you have a planet and a moon, okay, imagine, you can think of Earth and the moon, or I like to think of like a planet that's got a lot of moons, like Jupiter, for example. So think of Jupiter and one of its small moons. Let's say that moon started drifting away from Jupiter. So here's Jupiter, here's Jupiter right here. It's an apple. And this marker cap can be the moon, right? And this is, okay, here we go. So as that moon drifts farther and farther from Jupiter, the gravity gets weaker. We would all agree with that. But this relationship is an exponential one. So if you double the distance, it's exponentially weaker. It's 1/4 as strong. So let's look at what that looks like graphically here. Let's say we're going to start. I'm going to pick this number because it's a nice one to divide by. I'm going to start at a value of 36 up here. So for a manipulated quantity of 1, I'm going to start with a responding quantity of 36. Okay, and I picked that on purpose because if I double my manipulated quantity 1 to 2, so I'm going to double that. Okay, if I'm doubling it, I'm going to, for an inverse square relationship, I'm going to square that, so it's going to be 4, but I'm also going to invert it. So it's going to be, it's going to result in a change of 1 over 2 squared. So I'm going to do the inverse and the square. So inverse means I'm going to flip the fraction, I'm going to make it on the denominator, do the inverse of it, and then I'm going to square it. So that's going to be a change of 1/4. So from 36 divided by 4, 36 divided by 4 is, what is that? 36 divided by 4 is 9. It took me a minute there. Let's see, so 9 is all the way down here. So 36 divided by 4. Okay, I'm trying to draw it down here to 9. Okay, so that's a pretty big drop for just a tiny little movement here. So 36 down to 9 for my data point of 2. It's a pretty big drop, and that's because it's an exponential relationship. We doubled the distance, and the gravity gets 1/4 as strong. Did I do that right? Yeah, 1/4 is strong. Divided by 4, not divided by 9 here. It got us to 9. So 36 down to 9, and that's divided by 4. Okay, let's triple the distance. Okay, so I'm going to erase this. So tripling the distance, or tripling the manipulated quantity, goes from 1 to 3. Now, if we triple it, we're going to do the inverse square of that. So let's do the inverse, 1 over 3, and then square it. So 1 over 3 squared is now 1/9. So 36 divided by 9 this time. 36 times 1/9 is going to be 4. So it's going to drop us all the way down here. Okay, let's do one more. Let's do times 4. No, wait, that doesn't make the math easy. I'm going to keep the math easy. I'm going to skip over to 6. So I'm going to say I'm going to increase my manipulated quantity up to 6 here. So times 6. How would the responding quantity respond to that change? Well, if I'm doing times 6, right, I'm going to do the inverse square of that. So inverse is 1 over 6. Square that is 6 squared is 36. So it's going to be 1/36 as much. So I'm going to drop that down to a value of 1. Okay. And you might think that as we kept going here, it would eventually hit 0, but it doesn't. It actually kind of, smooths out here at the bottom, creates this kind of shape here. Okay. And this is an inverse square relationship. The equation for this is down here, y equals k over x squared. All right, so putting it all together, all 4 of the common mathematical relationships that we see in this is what we have. And I'll just, you can pause the video if you would like to record any of this to get an overview of everything, but we talked about these 2 in this video, quadratic and inverse square. These 2 are from previous videos, and this is just a summary of everything that we've talked about. So that's all I got for you for this video. Remember, how you do anything is how you do everything.